Well, thank you very much. I hope everyone is having a great Friday morning so far, and I appreciate you coming, especially if you're fighting jet lag. Um, I would like to talk about user-owned AI and effectively how do we actually chart the roadmap toward a user-owned model. And so I'll introduce this concept and talk about this. But for those who are not familiar with me, my background is actually in AI research. I was working at Google Research kind of before diving into the crypto rabbit hole. And I was working across natural language understanding, machine translation. I worked on TensorFlow, which was kind of previous generation deep learning framework. And I'm one of the co-authors of the paper Attention is All You Need, which introduced transformers, which is T in GPT. Now, I left Google to start Near AI back in 2017 with my co-founder Alex, and we were trying to actually apply the transformers, which just came out, to teach machines to code. And back then, that sounded like a science fiction and delusional. And so we were really trying to show that it's possible. And at that time, the kind of compute capabilities were way lower. And so we were actually doing a lot of data labeling, crowdsourcing with computer science students around the world. And we actually had this very simple problem. How do you pay people around the world in an easy way, right? People in, for example, students in China didn't have bank accounts. Students in Ukraine, by law, required to sell half of their dollars on arrival to bank account. So there's all kinds of restrictions and requirements around fiat that people needed to deal with. And crypto seemed like a very clear answer, right? This is how you can coordinate and pay people around the world, except back in 2018, already the fees on Bitcoin, Ethereum were way too high, the usability was way too low, and onboarding kind of even computer science students was actually a pretty painful process. And so that's when we started Near Protocol to really solve this problem, to build effectively a really programmable, easy to use, but most importantly scalable and cheap protocol that is solving our problems, but also solving everybody else's. So since then, Near Protocol has over 50 million monthly active users. We have use cases across payments, loyalty, remittances, as well as data labeling and other kind of AI applications. And it really serves as a basis for kind of kind of Web3 finance and AI applications. Now, kind of switching gears, the kind of conceptually, I really believe that the artificial general intelligence is very close, and you can almost say it's near. And the reality is, whoever controls the AI systems will control everything, right? We already see AI being applied in science, right? 2 Nobel Prizes last year were given to AI researchers. We see this in, everything from self-driving to manufacturing. AI is becoming more and more prolific across how it's used, and whoever controls how you can use it, right, how businesses can use it, how individuals can use it, will effectively be able to steer the whole, businesses, countries, and population. And at the same time, we have a very clear paradigm shift where we go from kind of how internet, like Web 2 developed, right, to become this, Googles and Amazons and kind of aggregators that have all the user attention, and then they route them to different applications and websites. Really, it started already transforming to, you're using Perplexity instead of Google, right, to just get the answer instead of going to the website. So we already have effectively AI agents or models that are going on your behalf to this website, to this documentation, to even applications, and doing actions on your behalf. And we believe the next kind of step there is this transition where the agents will become the main thing, right? The websites and apps will kind of dissipate because you don't really need now the front end anymore, right? Because you are talking to another AI most of the time. And so instead, you're going to have an agent network, right, where every business and every individual is represented with a set of agents, and these agents can take actions themselves. So this is kind of the agent network concept. And so as pointed out, it's really important that in this agent network, the control is actually on the side of the individuals and companies that are running it, not of some third party that provides the technology. Now, on the monetization side, there's also an interesting concept, right? Right now, if you're a AI company, be that foundational model or a software company that builds products on top, you effectively have two options. One is you can go kind of traditional route where you keep everything closed source, and now your customers need to give all of their data to you, right? You need to handle every single interaction. You need to handle data protection. You need to handle kind of the load. You need to handle privacy, data locality laws. Like in Korea, for example, customer data cannot leave the country without explicit permissions. And so it's a lot of complicated kind of control if you want to be really compliant. Now, there's an alternative where you open source your solution, right, and everybody can run it however they want, locally on their own servers, etc. But open source on itself is not sustainable, right? You open source, then you don't make any money. And so in result, you effectively don't have capital flowing back to really continue innovating. As I mentioned, there's a lot of kind of challenges with the current closed source model, right? If you're a large kind of company that is trying to serve a lot of users, you now need to have on one side, you want to have clusters in one place because it's easier to control them. There is actual real challenges with securing model parameters, which are kind of highly valuable IP for those companies. But on the other side, you have this need for countries like South Korea to have data centers and models in South Korea to serve users here. You also have problems with energy consumption, where if you build everything in one place, like in Memphis right now, there's a massive data center built, but it actually sucks so much energy that they need to turn on all of the kind of fossil fuel generators and actually creating ecological crisis there. You also have the latency challenge where, if all the data centers are in Memphis and you are sitting in Philippines, right, there's a natural speed of light latency. And as I mentioned, for enterprises, this is becoming really important because they keep having their data leaked in different ways as they use these tools. And so making sure it's secure is really important. There's also a safety concern, right? There's some of the companies kind of use the safety as a reason to not release their models in open source because what if somebody uses this model to design, next chemical weapon or biological weapon? And the challenge is as these models mature, these risks are going to keep increasing, right? And so in turn, these companies will need to keep locking things down and really limiting how people can use these models. And so we really need a different model and approach for that. And that's what we call user-owned AI, is really turning around the model from companies trying to build a model for themselves to make more money to how do we make a model for users and benefit kind of their well-being and their economic success. And that's a meta kind of optimization function that you're trying to achieve. And in turn, kind of leverage that model and to really kind of solve all of those issues that I described. So this would also enable this agentic kind of network, agentic web, because this would mean that all the interactions for individuals are confidential, they're permissionless. You kind of know the rules of the game, right? If somebody publishes a model and it's restricted from using from developing chemical weapons, you know that ahead of time instead of rules are changing constantly. You have equal access for everyone. That's really important. Because as these tools are becoming more and more of a productivity boost, right? If you have any kind of misalignment on who can access it, right? This creates a very profound economic repercussions. You want to make sure that users are owning their assets, data, and power of choice, right? Again, you don't want the company that builds a model to dictate what users are going to do. And this is going to start happening more and more because these models can effectively be very suggestive. You want to have effectively community to control the AI capabilities, right? Not, again, an individual company decide what can and cannot be used. Importantly, as maybe kind of professionals or developers, you do want to know how the model is trained, because there's this concept of sleeper agents where you can encode and training data specific behaviors that only activate at specific time. And so if somebody's training a model and not releasing how they trained it, they can effectively inject something that will become malicious when you use it in specific context. For example, during coding, inject a malicious dependency and effectively steal all your money, steal all your data from your computer. And so you want kind of this verification of data that goes into the model. And so the one important aspect, though, is that user-owned AI needs state-of-the-art model. And that is a really hard kind of bar, because if it's not state-of-the-art, right, if it's just, right now, open source is kind of usually like 3-6 months behind, you are having this challenge that, people will not choose kind of lesser experience, even if there is like kind of this other benefits that come with it. And so, you want kind of a state-of-the-art model with verifiable data and verifiable training where you know exactly what went in. You can still customize it. And you want a continuous upgrade. You want continuously new innovation coming in. So really you want to figure out how to get not just a single state-of-the-art model, but actually a process with which we're going to have this kind of state-of-the-art models continuously beating, non-user-owned, corporate-owned and closed-source models. So we introduced this concept of decentralized confidential machine learning at GTC kind of a month ago, and this was the idea that we can actually provide a decentralized cloud where you have all the interactions confidential and permissionless. You have results that are verifiable, be it training or inference. You can have data centers kind of participating in this around the world, so you can actually safely route models everywhere, but you still have monetization, right? It's not pure open source where you don't have any money made from releasing a model. Here you actually are generating revenue if you're releasing a model into the system, but it still offers you all the same services that you can do with open source model, like fine-tuning, distilling, and extending models. So that's kind of the main concept. It's built on top of this idea of trusted execution environments, which is a novel, it's been around for a long time, but as of kind of a year ago, it's now possible to do with NVIDIA GPUs combined with Intel and AMD CPUs, that you can have a full confidentiality even from the owner of the hardware of what's happening inside. And this gives you verifiability and kind of arbitrary computation, right? You can do any complex you can run databases, you can run data processing, you can do machine learning, kind of GPU-enabled inferences. And so kind of on top of this concept, we built this decentralized confidential machine learning cloud that really combines confidential VMs with GPUs or without, on-chain for coordination and payments, and a protocol we call proof of response to ensure liveness and kind of guarantees around transport level. So if you're interested in this, there's a whole paper around that. Now, as I mentioned, this is kind of fundamental infrastructure, but now we need to actually build this state-of-the-art kind of AI model that is continuously evolving. And so what we really need to do is, as open source and crypto communities, deconstruct an AI lab. Right? AI lab has a number of components that are kind of working together to produce these models. So first of all, it's data. There's a whole team of people who are working on acquiring high-quality data, making sure that public data is filtered down, because most of the internet is actually spam and ads, and so removing all of that and making sure that you have a high-quality data and you have curriculum on top of this build is one of the really big tasks. And so the way I'm suggesting we actually structure this is through a set of benchmarks. And so this is very similar how if you're working inside one of those big labs, you actually have all those different teams working on different aspects of the model training, but you cannot run, you don't run training runs on every single thing, right? You don't, if training run takes 3 months on 100,000 GPUs, you're not going to do that for every single experiment. And so there's a localized benchmarking that happens at every stage. So for example, if you're improving quality of data, you fix the model the model architecture, you fix the training procedure, and then you run effectively on a new data filtering procedure. You run this model training, and you compare how it performs compared to the previous version, right? So you're continuously kind of experimenting on this specific kind of fixing everything else in the pipeline on this specific thing on a smaller size. And so there's this concept of scaling laws, which I mean, they should be called scaling principles, but where you can effectively train like 2-3 models of different sizes and approximate how much the improvement you get if you train a bigger model, right? So there's effectively a curve plot of number of parameters to quality of model that you can and there's a kind of, you know, a curve for each of the kind of type of quality you're looking for, where if you train, you know, 1 billion parameter, 7 billion parameter models, you can kind of approximate how much quality will the model have at 100 billion parameter, 400 billion parameter, etc. Right? And so this gives you a framework with which you can actually iterate quickly on specific subsets of the training procedure. So for example, you have a new high quality data source, or you have, you know, maybe you're injecting textbooks, maybe you're creating synthetic data from a different model that is generating some new context or new way of presenting data. And so you can train the model on these different sizes and approximate how well it will perform at bigger size. And so similarly, you do at the pre-training, right? You want to continue innovating on algorithmic improvement. You want to ensure that, you know, new ideas, new experiments are being trained. Again, you train them on a smaller size, fixing data, fixing kind of the training procedure, and you testing how it would improve. Same for the training procedure itself, right? There's ways of improving how the model is trained right now, and you can test that as well. And finally, there's how do you actually distribute the training process, right? So this is more of an engineering task where you can actually improve the throughput of the training process, right? How much kind of tokens per second you can train on by optimizing how the data is pipelined, how the kind of model is split between this and variety of other parameters. Finally, there's a whole post-training fine-tuning team and set of benchmarks where you really specialize in this model either to answer questions, be an assistant, or tackle specific sub-problems. And so for each one of those, you as well have, you know, set of benchmarks and kind of competitions where you can have community to really come in and fine-tune these models, right? Because it's way cheaper, and you just offer the again, this process of verifiable computation to them to really run it on to kind of know that the whole process has been verified and you know which data went in and what kind of results were achieved. So the idea that you can use this verifiable and confidential compute to leverage kind of to decompose what right now requires high trust environment, right? Right now everybody sits in one AI lab, shares the code, shares the benchmarks in one place. You can decompose this now into kind of independent open source open source contributors to really participate in a competitive, kind of cooperative and competitive environment to really solve these problems together while not needing to trust each other because they run on a verifiable computation and they're getting kind of the benchmark results are really verified and you know what inputs that went into it. So the final idea is that, you know, as we're building this user-owned AI model, we need this kind of decentralized training that can work across decentralized clusters, especially now with more reinforcement learning, where, you know, there's 100 times more sampling happening than parameter updates. You can do this at really big scale, and you can train it in such a way where the outcome is not actually the parameters of the model of the outcome are not known to anyone, right? They are in the system, they're inside the trusted execution environments, but they're not extractable. And so you do need to pay to use this model, right? You do need to pay, and that creates a monetization model to feed back to kind of train the next model, pay the contributors, and for hardware. And so this really creates kind of this like flywheel where, you know, you're running benchmarks, you're rewarding the contributors, you train a big model, now everybody can use it, maybe distill it into or fine-tune it in specific problems, and then the revenue generated from using this model is feedback to pay contributors and train the next model. So now you have a kind of flywheel loop where you can have this trained in kind of this user-owned approach where you know what went in, you know what decisions were made, you know how it works, but it is still monetizable and kind of owned by the community as a whole. So I'm out of time. I really appreciate you kind of learning about this. We're going to be publishing more about this process and some of the tools around this. But meanwhile, for the hackathon, check out Near AI, and would love to see your hacks. Thank you.